Hello and welcome to Statistically Significant. In this session, I will be discussing the two-way analysis of variance with more than one observations per cell using MS Excel. Now, just have a look at a bit of the theory which is working in the background. Two-way Anova model is like this. It's Yijk equals to mu plus alpha I plus beta j plus gamma ij plus Eijk, where Yijk is the kth observation corresponding to the ith level of factor A and jth level of factor B. Mu is the general effect. Alpha I is the additional effect due to factor A. Beta j is the additional effect due to factor B. And gamma ij is the interaction due to both the factors A and B. Now, in the two-way ANOVA model with one observation per cell, we assume this gamma ij to be 0 because we had just one observation per cell, and when we have just one observation, it is generally not possible to get a better estimate of the interaction of the two factors. Now consider an example. Suppose a girl and a boy have gone for a date. In the first date, it is not possible for any of them to get to know everything about the other person. Now when they increase the number of dates, date 1, date 2, they get to know each other in a much more better manner. That is, when they replicate or when they increase the number of dates, an interaction is developed between the two people and they get a better estimate of each other. The same principle works here. I just use a funny example. I hope you got to understand this thing. Eijk is the inherent error in the model which follows independent identical normal 0, sigma square. Sorry. Our first null hypothesis is that there is no significant effect on the responses Yij due to the factor A, against the alternative that yes, there is a significant effect on the responses due to the factor A. Our second null is that there is no significant effect on the responses due to the factor B, against the alternative that yes, there is a significant effect on the responses due to the factor B. Sorry. And the third hypothesis is that there is no significant effect on the responses due to this interaction effect gamma ij, against the alternative that yes, there is a significant effect on the responses due to this interaction factor gamma ij. Now our test rule, I'm sorry for my handwriting. We reject the null hypothesis if the f observed values exceed the f critical values, and we accept otherwise. We accept the null otherwise if the f observed values are less than the f critical values. Now moving on to the problem which we have. This is our problem. Here these entries are the birth weight of babies, and then the rows we have the order of gravida. Gravida simply means the number of times a woman have become pregnant, and this is a factor which is affecting the birth weights. And the second factor which is affecting the birth weights is the age group of the mother. We have different age groups here. See, we have 5 age groups here. So we are using the two-way ANOVA, and we have m observations. We have 3 observations per cell. Here m is 3. So we are getting an estimate of the interaction of the two factors in a better way. So we are using the two-way ANOVA model with more than one observation per cell, and we are considering this interaction factor here. The birth weights are affected by the two factors. The factors are the order of gravida and the age group of the mother. Now the problem. Now in Excel you have to enter the entry of the data is very important. See, here I have 5.1, 5 and 4.8 corresponding to the order of gravida 1 and the age group 15 to 20. Here the capital A, B, C, D and E, they are the age groups. See, I have also explained these here. A is 15 to 20, B is 20 to 25, C is 25 to 30, D is 30 to 35, E is equal to 35 or more. And the small a, b, c, d, e are the order of gravida, that is, it's 1, 2, 3, 4, and it's 5 or more. Our null hypothesis is there is no significant effect of the order of gravida on the birth weight of the babies. Against that, yes, this is not true. We have a significant effect of the order of gravida on the birth weights. Our second null is that there is no significant effect on the birth weight of the babies due to the age group of the mother. I haven't written it, sorry. The age of mother. So our second null is that there is no significant effect on birth weight of the babies due to the age of the mothers. Against that, yes, there is a significant effect on the birth weight of the babies due to the age of the mother. Our third null is that there is no significant effect due to the interaction of the two factors, the order of gravida and the age of the mothers. Against the alternative that yes, there is a significant effect of the interaction factor, due to the interaction factor, to be precise. Now, see, here we are given the data like this, 5.1, 5, 4.8, but in Excel, to read it in a better way, I have entered it like this, 5.1, 5, 4.8. There is cell, I have left two cells, and then again the second order of gravida, then the three observations, then the third order of gravida, then the three observations, then the fourth order of gravida, then the three observations, and then the fifth gravida order and the three observations. The entry is very important. If you find any problem regarding how to enter the data for true analysis of variance with more than one observation per cell, you can write down in the comment section below. So now I will be using the data analysis package. Yes. The input range, select. Yes, we have 3 rows per sample. See, these are the rows 1, 2, and 3. The level of significance alpha 0.05. The output range, we select. Yes, we have our calculations, and the most important thing for the interpretation of whether to accept or reject the null is the Anova table. So now the sources of variation. The sample means the rows, that is the order of the gravitas. Okay, the columns are the age groups. Interaction is the interaction due to the two factors, and within means the error. It's the error term. SSE is the sum of squares. Is the sum of square due to the order of gravitas, sum of square due to the age of the mother, sum of square due to the interaction factor of the two factors, and this is the SSE, the sum of squares of errors. Now, how this DF is calculated? We have 75 observations here. You can see 75 totally, and we have 5 orders of the gravida. So that's 5 minus 1 gives 4. We have 5 age groups of the women. That's 5 minus 1 again 4. Totally we have 75. Is 75 minus 1, 74. The interaction is the DF for the interaction is obtained by multiplying the DFs of these two factors, that is 4 into 4 gives us 16, and 74 minus 16 plus 4 plus 4 it gives us 50. That's the degrees of freedom for the error. Now the MS is the mean sum of squares. It is obtained by dividing this sum of squares by the corresponding DFs. So that's it. And now the interpretation section. The f this is the f observed values. This is obtained by dividing this mean sum of squares for the order of gravida divided by this MSE. This f observed is obtained by dividing the mean sum of square for the age group of mothers by the MSE. And the interaction is obtained by dividing this MS interaction due to the factors A and B by the MSE. Now the critical values are this. Comparing, we see this is way larger than the tabulated value, so we reject the null. We reject the null that there is no significant effect on the birth weight of the baby due to the order of gravita, and we accept the fact that yes, there is a significant effect on the birth weight of the babies due to the order of gravida here. Now for this thing, again this f value exceeds the critical value, and so we conclude that yes, there is a significant effect due to the age group of the mothers on the birth weights of the babies. This f observed value, the interaction, this time it's less than the critical value, so we conclude that we have to accept the null in this case, and we conclude that there is no significant effect due to the interaction of the order of gravita and the age of the mothers on the birth rate of the babies. Now this interpretation could also be done using this p-value. Our p-value is here, you can see these are the p-values. Our level of significance, we took it as 0.05, so this p-value is less than 0.05, so we reject the null. Again this p-value is again less than 0.05, so we reject the null. Now this p-value is more than 0.05, so we have to accept the null. Now why I am saying this? Because the lesser the p-value, the greater the evidence of rejecting the null, and the higher the p-value, the greater the evidence of accepting the null. So that's it from two-way Anova with more than one observation per cell. If you find any problem, you can write it down in the comment section. Do like, share and subscribe. Thank you.